What I thought I'd do is show you another way of picking up an object, this time using a script to track it. So what I'm going to do, I've got a little bit of presets. I've got a little bit of a scene, simple animation, and I want him to put the object on the table. So just to make it a little bit easier to see what's going on, I've put a little sphere stretched so you can see which way up it is, and I've dropped that on the desk. That's where we want to drop the object off. I've also added another position over here, put on a funny angle, and the way this actually works is one of the problems I've had with animation is if you change a parentage, I had a few problems with it, so I don't know if this is the right or the wrong thing, but what I ended up doing was creating my own script, which here I've called TrackObjects, and you can give it multiple targets. I've hard-coded it with 3. I tend to find it enough. And what I've also done is then for my character's hand, underneath their left hand, I've created what I've called hold. And the idea is this is the position underneath the hand, so it'll move with the hand, that if it was holding it, this is where you'd want the object to go. So what we're going to actually do is we're not changing the parentage of this flower pot in the hand. What we're doing is we're associating it with 3 other objects via these settings here, and you tell it the 3 objects are one. I've told it the hand is one position, I've told it the desk is another position, and I've told it this point off in the middle of nowhere is the 3rd position. And what I can then do is by using these weights, I can, if the limbo point is 100% and the desk is 0, then it'll be in the limbo, and then I can decrease the weight of the desk and increase this one. And so if I have the 100% weight on the desk, you can see that it's pointing straight up and down now, and it's in that position. So the idea is to animate these sliders, and the other one is to go back to the hand, and if you set it to 0, then it will be in the hand if I've got all the offsets correct. And so I can control the relative position, and so now I can move things around without changing the parentage. Now it's a bit funny, if you set all 3 to 0, it's sort of like, what the heck, I don't even know what that means. But the idea is normally you'd have one as 1 and the others as 0, and then you'd at the same time animate one, and you adjust them both at the same time. And I'll show you how to do that next. I'll show you the script in a little bit. You're probably not going to be able to read it on the screen, but let's try and animate it then. So I'm going to take my flower pot, I'm going to drop it down, I'm going to create an animation track, and what I want, I'm going to record, and I'm going to set the hand holding to maximum. This one here is on the desk, I'm going to set that to 0, and this one I don't really need, but I'm going to set that to 0 too. And by moving them, I've got a now recording, so I've got a value there of all 3. Then I'm going to come to about here, and I'm sure there must be a better way, but I'm just adjusting each of these values back, and that creates another recording point here. A little bit hard to see, but there's a point there. So I'm going to move forward a couple of frames, and now I'm going to say, well, I want the desk to win and the hand not to win. And it's created another recording point, and I can turn off the little red dot, and so it's no longer recording. So what's going to happen is everything is still 100%, and if you watch these values over here as I move along the timeline, when it gets near here, it's going to then adjust between the 2 values, and it ends up the pot goes on the table. So you can see the hand goes there, and chop, it drops it onto the table. And that's because expand this out a little bit. The target 1 weight starts at 1, which was the hand, and the target 2 weight is at 0. And then later on, you notice these values are changing, and it's sliding over to the other one. So now the table weight is 100, is full weight, and the hand is 0. And so it will no longer follow the hand anymore. So we come back to the timeline. Notice the hands go away and it doesn't follow. And so it's really just sort of saying, well, who's got control at what time? Okay, so that's this was done, as I said, using a component on the flower. I call it track offsets. Might call it something else later. And it's really just got multiple targets. You can have any number. I've found that if you have an array, it's very hard to animate them, and so I've just hard coded in. I picked 3, but you can add more yourself. So let's have a quick look at the script. I'll try and at some stage put it up as a gist or something like that and put a link in the notes, but let's have a look through it to start with anyway. Oops, sorry, just trying to get the right window up to make sure I can see what's going on. Okay, sorry if the font's a bit small. I'm just going to race through it and I'll try and post a link later on. So it's got using Unity engine, because I need to use Unity stuff. This execute always is quite useful. What execute always in square brackets on the annotated on the class does, it says even if I'm animating and I'm messing things around, I still want this script to run, not only when you're in play mode. And so it's really useful with animation things, because we're going to try and animate these things in preview mode, and this means the script will run it also in preview mode. If you don't know scripting, well, I'm not going to teach you scripting from scratch. I'm not going to teach you C+ from scratch, but this is just to give an idea of how this all fits together. You say I want a field, which is a transform, which is the first target, and then we've got a range between 0 and 1, which is the target weight. This represents target 1 and target 1 weight. Because I've given it 0 to 1, it knows it can put a slider there, and it goes from 0 to 1. So that's the advantage of that little annotation thing, this range thingy in square brackets. And then I've just repeated for target 2 and target 2 weight, target 3 weight. And the transform just means you can drop any object in it and it will pick up its location from this transform. Update versus late update. Late update just gets calculated later. I don't know if it really matters. But then it calls the recompute function, which is where all the real work happens. So it says, look, if you didn't give me a target 1 or a target 2 or a target 3, just make sure the weights are set to 0, and then it counts the number of things that have got a weight greater than 0. And if all 3 are 0, and so there's nothing, it just says, I'm not going to do anything, and just returns. You get into a nasty thing with maths if there's nothing in there. And then work out the maximum of all 3. I just add up the 3 weights, and so if all 3 are set to 1, it's really going to go 33, 1/3, 1/3, 1/3 between the 3 of them. So this is just a way of normalizing between them. But it also means if they're all 0, well, it just gets a mess and you can't divide by total weight, because you could be dividing by 0. That's the reason for this checkup here. So I work out the average position, starts at 0, the average rotation, which is starts at the identity. So a quaternion, however you pronounce it, is for rotation angles. They're clever things beyond my scope to explain here, but it's basically recording what the rotation is. So identity means don't rotate. So then we say, look, if we've got a target 1 that we want to do, and it's got a weight greater than 0, great, we're going to add it into the average position. So we're going to take the target 1 position, and then we're going to take the weight divided by the total. So this is how we turn it into 1/3 instead of being 1. So if all 3 of them are of 1, the total weight will be 3. This will be divided by 3. So it's just scaling the weights based on the total weights. And then for the position, so that the position, you just add in the position times the weight. For the rotation, you do this dot product, quaternion slurp of the identity vector to our desired vector, and then weighted again like the other one, weighted by our contribution to the total weight. And by doing this, which is from this URL up in the forums, it combines the rotations of the different objects. And so this whole thing here is to do it for target 1. It then repeats for target 2, repeats for target 3, and then finally the position is the average position, and the rotation is the average rotation, and that's what moves the object around in the scene. These ones actually move it. And so that's why we're able to do things like put something on the table. And so just to repeat, the actual object is not a child of the hand. What it's doing is it's tracking the position of things, and you can tell it which of these three things to track. So I've put the track object script on this upright flower object so that the position of the upright flower tracks one of these other objects, or halfway between them, because you can do all the funny floating in the air sort of business. But it doesn't like it when they're all zero. So you can do this sort of fancy sort of floating in the air. Which is cool. Well, that's all I wanted to show. I'll try and put the a copy of the script up somewhere publicly so you can just have a look at it. We can always add a fourth weight or a fifth weight, as many as you want. It's a little bit hard coded, unfortunately, but you can't have everything. Yes, you could turn it into for loops, but then you can't animate these properties very easily. In fact, I don't know how to do it at all. I can animate public fields easily, but I can't animate members of an array, which I need to be able to do down here, which is why I've hard coded the number of things. So you can pick 4 if you like. Anyway, hope that was useful. That's an example of a script to tell an object what to track, allowing it to track a hand, for example, so it can be picked up